Hello to everybody who's joining us tonight. We will be starting in about 3 minutes, just giving a bit of time for anyone who's running late. Okay, we've got a good crowd going here tonight. So yeah, everybody who just joined, thanks for joining us, and we're just going to start in about 2 minutes, just for anybody else who's running late. I'm just checking that my audio is working as well. If somebody wouldn't mind just typing a 1 into chat to make sure I've got my audio levels are good. Awesome, thank you, thank you. We'll be getting started in about 1 minute. Okay, let's get started. Yeah, thanks to everyone who showed up tonight. We've got a lot to cover tonight, a lot of really good information about becoming a DevOps engineer, and a very experienced DevOps engineer is with us tonight to tell us all about that, so we'll just get right into it. We are bCloud Ready. I'm a data scientist at bCloud Ready, and Shannon, who's with us tonight, is our chief data architect and DevOps engineer at bCloud Ready. We produce both like commercial projects for that basically deploy artificial intelligence to cloud, and we also do training and placement and corporate training as well. So a little bit more about us here is that we are a Toronto-based startup founded in 2015. We do AI and cloud products. We have consulting services and training and placement. Some of our DevOps corporate training clients, so Wells Fargo, Capital One. We've had the privilege to work with some pretty great companies, some pretty big names down the States, and we do it both in Canada and in the States. And so yeah, this is Shannon Kumar, who's going to be joining us tonight and explain a lot about DevOps. He's our chief data architect, and this is his LinkedIn. We've got a link there for him if anybody's interested in that. And yeah, he's done some really great work. And so yeah, we're gonna get right into the history of DevOps, which is principles and practices, and I'm going to hand that over to Shannon. Here we go. Hopefully, I think Shannon, now you're unmuted.
Oh, hi. Hello, everyone. I hope you have a good evening. Today's weather is pretty nice as well. So without further ado, I'll just start a little bit background about DevOps. And so the whole thing about DevOps is actually right now a lot of people think is a new concept. It is new in a way that the way it is right now resurfaced. DevOps has been there for decades and decades as a philosophy as far as in mostly technology company. When I say technology company, mean who make their living by selling technology. It means your say big telecom companies, not the Bell and Rogers. Telecom companies mean like Ericsson, Nortel Networks, if you're in Canada, and some other like you have any technology company like Microsoft, Google, before that any IBM. So in any company where they are actually their primary job is to sell technology, they have been doing this for decades. But what changed recently? The thing changed was that a lot of things became, the market changed and things became a little bit easier to use for pretty much everybody. And that is where the non-tech companies like your bank, insurance company, and all these kind of enterprise customers, they realize that because the demand for software is becoming going up like anything, and they also need to deliver software as fast as a technology company. That means they need to work like a technology company. If you need to work like a technology company, then you have to adopt all principle of philosophy that they follow. So that is where the whole new form of DevOps that you are seeing right now is happening. And plus with the cloud, it just exploded. So the next slide. So how a typical software company looks like. So when I'm talking about typical software company anywhere, say if you're working in any maybe e-commerce company or anywhere, so you have usually a front and back end developers. Then you have a QA, you have a project manager, then you have operation team, which could be admin and anything. So these things in a typical software company have been working pretty well for a long time. But there was one problem with this approach. If you go to the next slide, then you see actually pretty much every team, they have been working in their own circles. It means they are working on their own silos. What developers are doing, operation people don't know. What QAs are doing, they don't know. So there is a lot of, I will say, the team, they were not collaborating very well, and that caused a lot of friction. And these frictions were invisible when you were releasing your software once in a year. So once in a year software, I will say for many people, uh, um, whenever you think of a software, you think of your mobile app or anything. But believe me, it is a very small portion of the software team. Vast majority of the big large enterprises like your bank, your maybe you have insurance or your car insurance, these companies, they traditionally do not, still in many cases, they don't upgrade their software on a weekly basis. If you check your Facebook pretty much every few weeks you see Facebook has been updated, Facebook has been updated. But those software, they don't get that often upgraded. So what happens is even if your team is working in a silo and there is a velocity of the code, I mean how much it takes time and how many days does it take when a developer writes a code and it's delivered to the production. So the velocity, if it is like 1 year, then okay, you can live with the system. But the problem is when you have to deliver software on a bi-weekly basis or every month, then you need to increase the velocity. And when you have to increase the velocity, you cannot work in silos anymore. You have to break the silo. And now to break the silo, to increase the software development pipeline, you have to adopt agile methodologies. You have to bring DevOps. So the next slide talks about how a typical SDLC works, software development lifecycle. You have a planning, you have analysis, design, development, testing, implementation, and maintenance. So planning, analysis, what you see is mostly project managers, design, implementation, developers, testing is a QA, and then you have maintenance. This is your operation people come in. So when you have these things working in a silo and your velocity is not great, it is just perfectly fine. And this we used to work pretty well with waterfall model, which is when you release your software once in a year. If you go to the next slide, we'll see when Agile came along, and Agile was, it's not like Agile drove something, and it was, I will say, it's mutual because the market was moving. And the same way Agile came along in the software development cycle, they said, we cannot rely on a waterfall model where we create a requirement and freeze it. Rather than what I want to do there, I will keep the requirement changing as I go. Because the reason is simple, I myself do not know the requirement at this moment. So if you don't know the requirement at the moment and you have to go to the market fast, what you do incremental changes. So when you do incremental changes, it means instead of doing a one big bang upgrade in a year, you'll be doing small changes every month, every week, till you reach to a point where you are happy. And that is what is called iterative development, sprint-based development, scrum-based development. So that is what agile methodology is. And if you go to the next slide, this is called Scrum. Scrum is one of the agile framework. This is how you develop. You have a Scrum meeting, you have a sprint of 2 weeks, And this is how you basically deliver your project. And in that way, the velocity of your code is extremely fast. You can have like almost 2 weeks of velocity of a code. When I'm talking about 2 weeks, for if anybody who hasn't worked in a software company, haven't developed any software, you think, okay, what it is. But believe me, in a real world, it is a very, very big challenge. Because see, when you do a Hello World project, if you work in a college, school, it doesn't matter. You write something, okay, assignment didn't work, professor will give you a little bit less marks. Nothing, there is no financial loss here, right? They won't kick you out of the college if you do the bad assignment. They will just give you bad marks, and next assignment you can do the same thing. So the criticality people do not understand till you have actually worked in something which makes the dollar, which means if your production server goes down, you will lose your job. You lose your job, you will not be able to, I mean, this, you will be get into trouble actually if something really bad happens. So you have to be very careful about that. So when some developer writes a code in their PC, and when they feel it is comfortable, it is released. But you have to satisfy many other customers, like many other team members, because for a developer, it always works on their PC. But beauty is that when it can work on a production system. So for sprint-based system, when you're talking about 2 weeks life cycle, you cannot have a tester, manual tester, and testing these things. It will take but maybe a month. You need a fully automated approach in that the moment developer writes the code and checks into the repository, immediately you fire like code check harness. Then you fire up QA automation harness. And then you basically do the deployment on a pre-prod. If it works, everything, then basically with one click, you can actually promote it to the production. And plus, guess what? Because the changes are so small, because you did a little bit, if something goes wrong, you can still have a time to roll back and bring back the older version so that no disaster happens. This way you mitigate your risk. If you see the next slide, and now there is a need for someone to work in a collaboration. So you have a software developer, a development team, QA team, and operation. Now they have to work in tangent, in together to deliver this task and on a completely automated fashion. That is what brought the whole new, I would say, sprawling industry as a DevOps. So now you're looking for DevOps engineer and these. So this whole thing is that a DevOps engineer or a professional, they are working with 3 teams at once. They have to know a little bit about operation. They have to have a developer mindset, and they should understand a little bit about QA. In this case, I want to say that you don't have to be rockstar developer, rockstar QA, neither rockstar operation, but you have to know everything enough. And because you will be wearing multiple hats, there is a reason they pay you extra dollar to the DevOps. So we go to the market, and you can clearly see that there are a variety of DevOps roles. And this is, I usually talk in many detail when I basically go for like a 1 hour DevOps session. In that, we talk about basically DevOps is not a job role, it's rather a philosophy. And how you implement the philosophy, how you bring about the culture in your company. These are the job roles: site reliability engineer, cloud engineer, DevOps engineer, cloud architect. Today I posted a blog also on my LinkedIn. I talked about difference between a cloud engineer and a DevOps engineer. I will suggest you to go over and look at it. And over there, I try to articulate that how these skills are a little bit different. But if someone just want to start, and depending upon where you want to start and where you want to take your career, so that talks about in detail. So these are the pretty much job roles which are pretty much in the market. And because you will be wearing multiple hats, so the organization is willing to pay you a little bit extra money than market rate. If you go to the next slide, you see, so CI, so DevOps is, as I said, it will be multiple hats you are wearing. So multiple hats mean you'll be doing multiple jobs like CI/CD, which is continuous integration and delivery. Why? This is the thing which increases the code velocity. You can deliver faster. Infrastructure automation. It means if I need a resource, if I need say a bunch of compute resource or storage or something, I don't have to wait for 1 month, 2 months to get everything done. And if any one of you haven't worked in a larger organization, this is a pretty big challenge. To get a resource, you have to wait for 2 to 3 weeks, because many places they are still using previous generation philosophy, in that you pretty much have no automation. You need to have someone manual intervention to do that. So with infrastructure automation, you are increasing the speed of that as well. Then you're managing relationship within operation, because I said, because you are breaking down the silos, you have to work with different teams. And when you work with different teams, you have to understand a little bit about their tools and failing intelligently. That is the most important, because as I said, you will be doing small changes. If something goes wrong, it should be easy to fix. And the fix should be automatic. It should be completely automatic. It should not be someone is logging in and doing something over there. So these are the few things about DevOps that is which solves a problem in today's world. Next one. So use cases. So this is a pretty classic use case, like development team needs 5 servers and operation can't prepare those things. And this is a very realistic case. And this is where DevOps philosophy comes in. It's not like DevOps engineer will come and give you a magic pill and boom, you take the pill, you got the VM. Or to the same case, it's not any magic pill is available. Someone will take and they will become a DevOps engineer. This is why we call about a journey to become a DevOps engineer, rather than I become DevOps engineer in one day. If that was the case, then why someone will pay you 100, 150K? If something is so easy to learn, it is as easy as driving Uber, they will pay you $15, right? Why if it's so easy to do, so easy everything is doing to do, then how it is, why someone will pay any money? Like for a grass cutting, it is an easy job. Do you pay someone like a $100, $500 an hour? No, you pay them $10 and $15 an hour. So always remember, anything which is more difficult, more challenging, and has more responsibility, the dollar value goes up on that. So this is the classic case where DevOps actually solve the problem. If you implement DevOps philosophy in your team, and you have DevOps engineer to execute this task, developer, if they ask a resource, it is available with a click a button on a Jenkins job. Next one. So this is some of the example, like I think from Puppet. So they said that high performance organization deploy 200 times more frequent low performance code and they basically do it faster. So it means usually a high performance organization, if you have to be high performance, like if I say the best of the breed, I will compare like say Facebook and Amazon. They must be deploying millions of code, like a lot of changes every day, it is like a super fast velocity. And that is why they are more efficient organization. Less efficient organization deploy lesser codes because they are also scared because something will go wrong. But if you have a fully practical DevOps philosophy implemented, this can be achieved. Next one. So these are some of the major tools when I'm talking about DevOps. So first thing, I'm not sure if you can see the green color, is just too much light. Maybe we share. So first thing, the major tool stack, I will say right now, what is going in the market. Because of course you want to be DevOps, you don't want to learn forever, right? You want to eventually go into the job market and deliver a value, do something about it. So for that purpose, primary tools are, you have your Docker, Kubernetes, which is pretty much everybody's using for orchestration. Git is very essential. Without Git, you cannot survive in the market. Jenkins is one of the hottest tool in DevOps or any QA automation developer, you name it. It is a very wonderfully created orchestration tool where you can hook up multiple plugins to deliver value. Ansible, which is right now, I will say, the most popular configuration management, I will say infrastructure automation tool available in the market, and it's very easy to learn. Then you have Terraform. Terraform is for infrastructure as code, and this is very valuable if you are having a public cloud setup where your whole infrastructure is sitting on a public cloud. You can write a Terraform to basically orchestrate the whole infrastructure in a form of a document, so that next time if you have to create infrastructure, you do not have to click a button. I will give you an example. If I ask you, hey, can you spin up a WordPress website for me? If spinning up assume you're doing the WordPress website for first time, You spin it up. It took you maybe 3 days or something. A lot of issues were there, and you come back, and then I ask you, hey, can you spin up another WordPress website for me? Then what happens is that if you don't have any kind of automation, you will take same amount of time again, same amount of time again. But beauty of having configuration manager or infrastructure as code, next time if I do, you just execute a code and boom, your system is up. And we'll do a quick demo here today, show that how we can use like Ansible and AWS to quickly spin up a WordPress website within few minutes. Then you have Grafana and ELK is pretty much red hot right now as far as the monitoring is good, because nothing is good in this world if you cannot monitor your infrastructure. That is where Grafana and ELK comes. ELK is Elasticsearch, Logstash, and Kibana. And of course, last but not the least, you need Python. Python, why I'm saying you need at least some programming language to make your life easy. And this all tool, you must know how they work with each other, with together, because this is what actually differentiate from a newbie to a professional. Newbie might know every tool in a bits and pieces. You know, from here I did a Udemy course, or from there I did LinkedIn learning. From there I joined this one. Okay, I know. I can write a code. I can do this thing. But can you integrate everything together and finish up a project which generates revenue? That is why people are hiring you, right? Why someone is looking for a job. And by the way, as a business owner, say I am, why will I hire someone? I'll hire only if that person can help me to deliver goods and services to my consumers. That is how the dollar value is generated, and I'll get some, I'll pay some. If you cannot finish any project, then you are not good for the organization. And that is the where you need to focus more on basically doing some projects done. Open source, doesn't matter where it is. You learn the tool and implement it. Learn it and implement it. Next one. So must have DevOps tool. So I think next one, I think it's the same slide. Yeah, we can go on again. So some of the tools I said, implementation tooling about DevOps, you have a build automation, test automation, deployment automation, monitoring and alert, failure and rollback. These are pretty much, I will say, day-to-day job of a DevOps professional. Next one. And as I was emphasizing again and again, because you will be wearing multiple hats. So it means the salary range is a little bit higher than average developer. If you go to the average developer or a QA person, average salaries are not that high. Usually maximum you get around 100K, and salary, even the lower bottom salary is also not great. But median salary of DevOps is pretty good. It's across North America. Forget about North America, across the world. You go anywhere, you go to Europe, you go India, anywhere, DevOps people are actually making really good right now. So next one. So becoming a DevOps engineer. So I think becoming a DevOps engineer is that, I think before we do that, I would like to maybe quickly show a demo so that people can actually get an understanding about what is going on. So I'll show you the slide before actually Nicholas takes things and explain. For example, I want to show you something like there's a very simple, I'm not sure if you guys are familiar with Ansible. This is how a typical Ansible playbook looks like. In this one, this is called a classic example of a configuration management, or sometimes people use Ansible as an infrastructure as code as well. In this one, what I'm doing here is I'm creating an EC2 instance, which is a Elastic Compute 2 virtual machine in Amazon. And in that, I'm giving an AMI, and I'm giving a bunch of parameters like my SSH key. And then what I'm doing here is I'm running a role, which I have developed, I've written. What it does is basically it spins up, say, a WordPress website. So right now I'm giving a classic example of building a WordPress website with just, see, this is the code has been written. Of course, I'm not saying code you can write in 5 minutes, but during the process, you will be writing these kind of fully integrated orchestration layers, which will increase the productivity dramatically. Right now, if I want to install a WordPress website, probably I have to go to the documentation, I have to find this and that. And after doing that, once I got the documentation, I have to go to, maybe even if I use Amazon, I'll actually double clicking it, creating an EC2 instance. After creating the EC2 instance, I'll probably go follow the documentation, install a bunch of libraries. And after the library, then basically eventually my instance will come up. And this is what I'm doing here is I'm doing fully automated. So right now, see, basically what happened was that in the last instruction, it actually created an instance. So I got my Linux created and it gave me a public IP as well. And now on that public IP, this will be actually now executing my playbook, which is basically set of instructions required to install WordPress. Here, if you see, I'm waiting like 40 seconds because, sometimes it takes a little bit time for Linux box to come up, and I'm waiting, giving some kind of delay, 40 seconds. And after 40 seconds, I will start executing my code one by one. And this one is simply like gathering facts. And these are the instruction I'm giving. Then I'm installing Docker and Python pip. So this is called like a fully unattended orchestration. I'm using automation tool called Ansible, and I'm installing pretty much, this includes installation of PHP, Apache, MySQL, setting up the MySQL, pointing it to that. So we are doing a lot of things here, and we just have to give maybe a few minutes and it should be up now. So how do I check? So this is my public IP, I got it. Public, this is the host name. So this looks like up. So I can go to my, see, this is the host name I had. See this one, same. And if you can see this thing, see my WordPress is up, and I can go ahead and install it. And if I want to do it a little bit more fancy, probably I can put more steps after this, and I can do this configuration on the fly. So you can have the whole thing automated on this one. So I think yeah, I'll give back the control to Nicholas. Nicholas, you can take it from there.
Yeah, sounds good. Um, there we go. I'm just going to share my screen again here. Yeah, thanks very much, Shandon. I think the automation really is kind of the coolest part for me, like we were talking about earlier, just that, um, once you have the settings in place, you can repeat it over and over, and how kind of all the tools come together to save companies a lot of money. Yeah, it is very cool. So Chin and I have talked basically a lot about how students can become DevOps engineers. So he and I are kind of worked through that together with you guys, because I think if you see that you use all these tools together, it does create really huge value for companies, and there is, the salary is really wonderful. So hopefully you're kind of interested in becoming DevOps engineers, and hopefully that's why you're here as well. So we're gonna just kind of give you some tips and yeah, work through it. So kind of these are some secrets that we have for entering into DevOps. So the first thing is that you don't need to be a software developer to be DevOps. We're actually going to be covering a bunch of roles that actually transition nicely into DevOps as we go on. The next thing is that the tech stack is huge, but you'll start off doing something with a limited scope, so don't be discouraged, right? We have all these different technologies going along, and obviously that can be overwhelming, but again, so I'm going to jump to point 4 here actually, is that you don't have to be amazing at each tool. You need to be very good at one thing, and that main skill kind of gets you the job. So again, you don't need to know all of it. You need to have kind of a jack of all trades, have a broad idea of all of it, but then be very good at one thing. And then academic learning and certifications, they aren't enough. You need to work on a live project. And we do have, we have some stronger suggestions about how to get that live experience and how to have a mentor and stuff coming up later on. But for now, going to GitHub and start contributing is a much better way than just taking Udemy course after Udemy course. So yeah, these are kind of our big secrets for getting into DevOps, and they have helped a lot of our students get jobs and get placed in the past. So yeah, what type of positions transition to DevOps engineers? So new graduates, people are somewhat surprised sometimes to find that you can be a new graduate and become a DevOps engineer, or freshers, as some people call them. Operations people, so system admins, IP, Windows admin, QA testers. So we were kind of talking quite a bit about how manual testing is being phased out, and it's being replaced by the automation that Shannon was showing us. So these people often do, if you pick up the automation skills, you can become a DevOps engineer. And pretty great. Software developers, of course, although that you don't have to be that. Data engineers. If you come from like a machine learning background and you do pick up enough cloud skills to be able to create data pipelines, you can transition into DevOps as well. And database administrators, of course. What type of people make excellent DevOps engineers? So you have a technical background and you want to take it the next step, of course. People who are interested in cloud computing. Obviously the operations environment is heavily online these days. Distributed systems. So being interested in cloud and is obviously a huge prerequisite. But I think like most people who are in software are very interested in cloud. Um, Finds it exciting to learn about new technologies and tools. Some people just like to have one thing that they focus on all the time, and like we were saying, you should have your main skill for sure. But I love just learning about new stuff, just because it's so cool. It's so crazy what people are making these days. And likes automation and creating business value. So the automation part is really like all through human history, doing more with less human engagement has been one of the things that drives us forward. In terms of value. So yeah, that's kind of what it's all about. And so challenges to becoming a DevOps engineer. So lack of experience or lack of local experience, and the tech stack is the full tech stack is it is very involved, and technical expertise is a really it's sort of being a unicorn is something that people sometimes believe they have to be, but even getting to the kind of baseline level can be quite challenging. So to address these challenges, we've created a Journey to DevOps program. We've put a lot of work into this and a lot of research into different program options and things, different ways we could configure the program. So we hope that we hope that you'll see it as kind of a unique thing and something that is going to go a lot deeper than a lot of the programs in the market. We really did create it in response to a lot of the programs that are in the market, especially the courses that are going to be very hands off. We do take a very active role in students learning and especially their entry into a job position, a career position later on. So basically the overall structure is that we have a training phase, internship phase, and a placement phase. So the training phase, we start off with, it's a somewhat flexible program schedule. It's 3 to 6 months. It's part-time. So we do 8 hours of classes on the weekend. So people who can devote a whole lot of time to this, we can definitely set them up with more work throughout the week so that they can kind of accelerate their learning. But this does support people who have other jobs or they can only do part-time for this. The reason it's 3 to 6 months is that if a student is coming in with quite a lot of experience and they are quite strong, 3 months part-time is actually we find that that's enough to get them through the training and have a grasp of all the tools we showed before. Now, obviously, people do have to work very hard and they do have to commit, but we found that to be enough time. But students can, for no extra cost, extend it to 6 months if they find that they need that extra time. We basically do 8 hours of class on the weekend, and then we do a 1 hour follow-up during the midweek. So this is a follow-up not just for technical learning, but it's also a follow-up so that you can ask questions about if you find a job position that you're like, you know what, this is an entry-level job position, or if you're quite experienced and you want to go for a full like DevOps position and you're transferring from being like, a cloud architect or something like that, you can ask all your questions about what would be the best ways to interview for it, how to set up your resume, all these other things. Because again, people like Chandon that we have within the company, they've been hiring before. They have they have deep industry experience, and they can kind of give you a lot of tips about how to get those positions. Resume help, mock interviews, of course, and so we support you until you receive a position. The career mentoring is ongoing. There's not a stop date. We just keep supporting you as career mentors until you get a position. And one of the things we'd like to offer people as well is sometimes getting into a position, it can be kind of overwhelming at start. So what we do is we actually, because we have the technical expertise within our team, we will support you after you get your job for the first little bit to make sure you acclimate properly to the position. Like basically you're just confident you can do your job. And if you have questions, we'll actually help you with our technical expertise so that you're just like, you're comfortable in your position. Of course, once you know what you're doing in your job, and obviously you're not going to be asked to do everything day one, then people obviously are going to have much higher success rates. So here's our 8 week training phase. So you'll notice there's 6 things here. We reserve the other 2 weeks basically for any clarifications, any kind of extra work that people need. If you miss something, we can repeat it for you, and basically for any electives. So if you find a job posting and you're like, oh, I really like that, but we're missing one skill. I'm missing, whatever it happens to be from our training stack, then we can add that in at that point. This is kind of the minimum training stack that we find is very important for us to be able to place people and help people get positions. So this is where we start for 6 weeks, and then we have 2 weeks left over. So then after we do that, we move into the internship phase. So this is the first is 8 weeks, and that's obviously 2 months of the program. And the last month, basically, we do a live internship project. This might evolve into a full commercial project for a paying client. And at that point, we do work with the people involved with it to do possibly royalties and other things to make sure the students feel like they're properly, compensated for it. And so we basically start this as soon as you have the minimum technology stack that we were just talking about. So again, we have quite a lot of flexibility here because if someone comes in and they're, extremely strong in development or operations or whatever it happens to be, they might not want to do certain modules, and then we can help them in that time. We can help them grow their skills in the places that they are weaker, so that they're ready for they have this minimum total technology stack that we kind of need for them to start on the internship as soon as possible. Now, that might be day one for certain people, and that might be after 2 months for certain people, and it could be, longer as well. But we do have a lot of flexibility. We do training. Training does continue concurrently with the internships to make sure that you can kind of achieve the goal set out in the internships. We have coaching and mentoring at all steps. And basically, so when you can execute the tasks in the live internship, we move you to the placement phase. This is very important because basically the tasks that we'll be giving you in the internship will be the same, will be, very comparable to tasks you'll have on jobs. Shannon has been a manager many times in the past, and he knows kind of like the scoping and the depths of the task that they would give to a person who's kind of a DevOps engineer. And so therefore he can, the training will be very much like, I want to use the fancy word of a facsimile, but really just something that's very much like being on the job. And when you can complete those tasks, you're going to feel very confident, and we're going to feel very confident that you can do a good job and we can place you in the market. Um, the placement phase is basically you find a job posting, and then we're going to work with you to make you a great candidate for that job. So again, this is when some of the elective time could come in and stuff. And so if you're missing one skill, let's get that for you. Or how are you going to interview properly? What do they think you're going to ask you? Like, what technical questions will they be asking you about certain technologies that are very specific to the job posting you found? And we're going to kind of build you up in the direction of this job posting. And obviously you're going to choose a set of job postings so that you can have, it's not just like you're putting all your eggs in one basket. And then we're going to kind of move towards that. And again, this is interviews, mock interviews, or mock interviews, interview prep, resume tips. So locality is a big thing. It's often not who you know, or it's often not what you know, but who you know. And so this is kind of one of the big things that one of the big features of the placement phase that we offer, and that's basically that we have a large network of recruiters. Oftentimes, recruiters will be tasked with, let's say, hiring for DevOps, and they won't have any idea what DevOps is. Development operations, all of that will be kind of mystical to them. So we run boot camps for recruiters to help them understand these technologies. And of course, in return for doing that, we've built up a lot of goodwill with recruiters. So we do get access to a lot of these job postings, and we can kind of, give you a very personal, introduction to recruiters who will be hiring. And of course, we know hiring managers, and then we will help you go through LinkedIn, and we'll kind of elaborate LinkedIn strategies that can help you get the position as well. So yeah, that's kind of it for the placement phase. So we have had these results basically, so that within 3 months we do have a 79% success rate. Within 6, we get up 9-1, and within 1 year, we've placed all of our students who've completed the program. DevOps is really, really hot right now. It's hard, but with the right tutoring, it's very much doable with somebody who has the right attitude and works hard for it. And because it's such an in-demand market and such a growing field, we can boast like very strong results when it comes to helping our students get positions. So just kind of some testimonials here. John's working at Infosys and Zone Networks, and then we've got senior DevOps engineer at Walmart Research Labs, which is pretty great. And yeah, so we have a refund policy as well. It's a 2-week money-back guarantee. If it's not for you, we'll give you a refund, no questions asked, so you can try with the program. It is quite low risk. So now we're just going to get into the fee structure. So the fee structure we've created this way, like we were looking at a lot of programs that were 12,000, 15,000, 17,000 upfront. And that can be pretty scary and pretty discouraging for students because the ROI, if it's not for you, like you're committed, and that's kind of just that. So what we did is we're so confident that we can place you, and we've done this in the past many times, is that we do 1,000 per month for the training period, and it's a max of 3 months. So if you find, you need 4 months to learn everything you need, 5 months, whatever it happens to be, you only have to pay the 1,000 per month for 3 months, and then you can kind of go from there, and you can repeat the training with us. Once we've placed you, so to be honest, for us, 1,000 is not a sufficient motivator because we have live commercial projects. People like Shannon are charging $150 as 50 an hour as consultants. Like 1,000 a month is not really that motivating for us, but we we are obviously very happy when we can place students, and that does mean a lot to us. And then so after you get placed a job, then it's $5,000, and the job has to pay you at least 50,000, and it has to be in DevOps. You know, if you change your mind or you make less money for whatever it happens to be. Now, obviously, the starting salaries are often much higher, and the salaries we get our students are much higher. But we do have this minimum cutoff so that because people always ask, and we don't want anybody to be threatened there, for a total program fee of $8,000. Now, we think this is extremely fair, given that a lot of programs are a lot more expensive, but they are full time. So we created this program to be able to, if a student has full time to devote to it, we will keep you busy. And you know, there's a lot to learn. We will keep you motivated. We'll keep you learning things. So you can scale your learning up to full time, but the classroom section is on the weekend to accommodate students that are part time. We have no problems though keeping you very busy if you did want to take this as a full time thing. And so from that perspective, we think that $8,000 is extremely fair, and it has a very high you know, the risk on it is quite low because you're only doing $1,000 a month, and then it's only if you get the job that obviously can scale up to a wonderful medium salary of over six figures that which you have to pay an extra $5,000. So you know, definitely something to consider. And yeah, this is just a recap of the program. There's a training phase, internship phase, placement phase, and we really do want to say that the access to our network of recruiters is one of the things that really helps people get you know a position, and that also when it comes to working with all these technologies, like we were saying before, academic learning isn't going to cut it. You need to work on a project, and you need to have a mentor guiding your learning for this stuff because there's just so many different technologies. Knowing how they're all going to work together is something that's you know like it's invaluable really. And then you have unlimited retakes of the training and access to career mentoring. So yeah, that's it. This is a Q&A section. If anyone has Q&A, and I do notice that we've got some questions coming in here. You can also, this is our registration page is at bcloudready.squaresite.com or .squaresite. And so if you can go there, we are looking for another I believe it's 5 students right now for our next cohort. So, you know, we would love to have you with us. And I'm seeing some questions coming in here, and I think Chandon, you're going to be more equipped to deal with Jenkins versus Travis CI, which is best.
Yeah, so pretty much they are the same, they are the different, I mean, same tools by different vendor. So it's like a Honda Civic versus Corolla. So which one is the best? There is no right answer, right? So which one is you are more comfortable and which your organization is using. So I think both are just, as I said, it's a different vendor, but they do the same thing.
Awesome. Let's see, you've got some more questions coming in here. How much coding experience is required to take the program?
I would say you don't need necessarily any coding experience. As I already mentioned, that you don't have to be a rock star software developer to become a DevOps, because if you go back to the slide, we had circles. So you need to know enough development in order to automate something. As a DevOps, nobody would expect you to write a object-oriented programming or writing complex Java classes, no. But they would expect that you do some basic Python code. You can just read a file or maybe do a get post on a REST API. I think that should be more than enough.
Another one coming in here that, yeah, someone's just asking for clarifications about how many hours it is on the weekend and like what days, like how does that break down exactly?
So as per current schedule, so we have 8 hours every weekend, 4 hours of classes. For example, this weekend we have a 8 hours Jenkins sessions, and which is like on Saturday 4 hours and Sunday 4 hours from 11 a.m. to 3 p.m. Yeah, I know it's a lot of time, but see, we are trying to squeeze in, we are trying to make you ready for the market in 6 weeks or 3 months. You have to be ready and you have to be committed to it. So hourly is that, and we try to, and the way we have designed the course is pretty much you can enroll anytime. So for example, if you can start with the Jenkins and then you can go to the Terraform. And so it's like a very circular fashion. And because this training is like that, you can attend as many times as you possible. So it's fine. You can, if something you miss this time, next month, you can, this will come along and you can attend the session. So overall, we are looking for around 30 to 32 hours of classroom sessions, interactive classroom sessions per month, plus few hours of mentoring session, which is mostly about working with how to get to the job market, talking about what to do, what not to do, and those kind of strategy. But of course, it's not for everybody. Like you will know, some people are more confident, and some people are maybe just want to take more some time. And I tell everybody, do not rush. Don't think that job will go away tomorrow. I have to apply right away. It doesn't matter how many you apply. If the skill set is not matching, nobody will hire you. So maybe you can wait a little bit, but when you go with a bang. That will be my answer.
So I've got just a question here about, because we were saying before about, it looks like they're asking if you're going to main one of the skills, and I think that means if you're going to focus on one to the point of being an expert in that, which like area or skill would you recommend focusing on?
I think current market condition, I will say, if possible, I will say make a good strong hands in Linux. If possible, if it looks too difficult, I will say pick up like a build automation, like Jenkins, and depending on what is your background, if you are coming from even a little bit of developer background, I think Python and Jenkins will be easy to pick up. If you are coming from operation side background, I will say you should go with the Linux and an Ansible. And I think these will be two minimum two things in the belt you should have. And because as I said, you don't need to be superstar in all the technologies. You just have to pick one or two, make them your strongest, and then just go in the market. And also, if someone is actually completely coming from operation side and they are having actually absolutely no development experience or may not have interest in development, for those people, I think instead of DevOps, they can do a cloud ops. So cloud ops is a more of an operation job, but doing the course and learning all these things, you don't have to learn everything, but at least you know enough to talk about it and also explain and understand. So you maybe stick with the cloud role, and you may not be doing development, but doing this whole course, the whole 6 weeks of course, will give you enough exposure to clear the interviews.
Awesome. I was getting a question saying, do students generally get contract positions or do they get full positions?
It actually depends upon the market. Actually, right now the market is pretty, everybody knows market is pretty dicey. So I will say at this point, you should not be choosing between contract or full time. I think whatever the opportunity comes, and you should just take it up. Stay there for 6 months, a year, and see how you feel, and then you can make your next move. Some people like contract, some people like full time. It is completely up to personal choice. But I will say at this point of time, you should not say no to anything. Whatever comes, just take it.
Excellent. Excellent. Yeah, I'll just give it a couple more seconds here. If anybody has any last minute questions, those are awesome questions, and thanks so much for sharing those. Yeah, if anybody has any more questions, and then we will wrap things up. Also, if anybody, I'm gonna just chat this out to all attendees. This is my email address that I'm sending to you. If you have any questions, please feel free to reach out to me there. We also do programs for machine learning and data engineering as well. So if you are interested in those, please come take a look. One thing we do always encourage people kind of to understand is that to become, let's say, like machine learning is obviously a very hot field right now. To either become something like DevOps or machine learning, you have to really choose a path and go with one of those two options. You don't want to do everything because that's not realistic and you'll become nothing. So yeah, very much. If you're interested in DevOps and this spoke to you at all, we would really recommend like sticking with this program and seeing where it takes you, seeing where DevOps really takes you if you commit to it. So yeah, thanks so much for your time, Shandon, and thank you to everybody who
Thank you
joined
so
us
much.
tonight. Yeah, and we'll be ending things here. So, all right, great. Have a good night, everybody. Take care.